Hello Precalculus student, this video is for chapter 3.9. Part 2 is joint variation and also use a variation concept to solve word problem. So what is joint variation? Joint variation occurs when quantities vary directly or inversely with multiple variables. And they will describe the sentence as this quantity vary inversely with another one and then directly with something. So usually they would use the word jointly for direct variation and then they would use inversely for inverse variation. But although they vary with multiple variable, we use one variation constant. So the basic equation would become having y equal to, so for example, in this example, a quantity y vary jointly with x and w. So we would say the basic information would be y equal to k jointly, both x and w. So it would be k, x, and w. Not adding, but multiply. It's all one multiplying. So now we have two variable, and this is a variation constant. So they will give us a pairs of values. So they observe that when x is 6 and w is 4, then y is 60. So use this. 60 is y. K, we don't know. Times 6 times 4. So 60 would be equal to k times 24. So k would equal to 60 over 24. And then if you simplify it, k is equal to 5 over 2. Okay. So then you would write the equation out, that is 5 over 2 times xw. So this is the equation that you want, and this is the variation constant. After that, then you can use it to predict y. What happens if x changed to x4 and w changed to 8, right? So you would say y is now equal to 5 over 2, x changed to 4, w increased to 8. So then you would do 2 times 8, 16. 16 times 5 is 80. So y, new value y is 80. In the past, when x is 6, w is 4, then it's 60. But because they are jointly related that way, we find that y become 80 if x become lower to 4, but w become 8. So that is called joint variation. So this one involves both direct variation and inverse. So let's see how it goes. Quantity y vary directly with square of x. So this is just like before, k x squared, right? And so when they say and something, that means joint variation. Inversely. So now for inversely, you just divide. You don't need to do another k. Inversely with z. So this is the basic equation. Now you use one set of value to find out k. So when y is 40, or when x is 4 and z is 2, y is 40. So we write 40 equal to k. X is 4 squared over 2. Okay, so 40 equal to 16 divided by 2 is 8. K times 8. So k is equal to 5. So based on this set of equation, we find the variation constant, and we can now write the equation out is 5x squared over z. So this is useful for any values of x and z now. So find y when x is 10. So we just 10 squared because they say it's square of x, right? Z is 25. So 5 times 100 over 25. This is 4. So 4 times 5 is 20. So y is 20. So that's basically what it is for joint variation. So you usually are given one variable very directly and inversely with something. So that is what we can use to solve question like this. Application. Distance S. They didn't say what it is, what unit it is. I think this is in meter. For the distance and object fall vary directly to the square of time. So there is no variable for this, so we'll just say t, okay? So, and that's it. So this is not joint variation, but s vary directly with square of times. So we can write the basic one here, basic equation here. If the object fall 19.6 meter, so this is a distance fall, 19.6, equal to k, 2 seconds. Second is in time, 2 square. So k would equal to 19.6 divided by 4. 19.6 divided by 4 is 4.9. So k would be 4.9. So we have the equation. Distance is 4.9 t squared. Now we would use it to solve. How long would it take for the same object to fall 313.6 meter? So this is meter. We have to solve for t, actually. This is a little different. We know s. This is distance s. So this would be 313.6 is equal to 4.9 t squared. So divide both sides by 313.6 divided by 4.9. 313.6 divided by 4.9, that would be 64. So divide 4.9, divide 4.9 on both sides. That's 64 in the calculator. So what is t? You do the square root of 64. It's positive. You don't need to worry about negative. That's equal to 8. So that means in 8 seconds, it would fall 313.6 meters. And that's the answer. In second. Okay. So this is just an application where it is a direct variation of one variable. The second one is also a is also a variation, but I think also one variable. The number of hours required to paint a house is inversely proportional to the number of workers. So number of hours, so let's say T then, right? Number of worker, let's say W. Sometimes they don't tell you, you just have to write the variable. And then you will say number of hour is inversely proportional to number of worker, like that. Inversely proportional. So that's the basic equation. It takes 3 people, so that means W is 3. Time is 10 hours to finish the job. So I would write 10 equal to K over 3. So what is K then? K is equal to 30 because I'm times 3 times 3, right? So now my equation is T equal to 30 over W. Now, what happened is then how long would it take? What is the time when W is 8? You increase more people. In the past, it was 3 people. Now you have 8 people. How long would it take? So in round to 2 decimal places, put in the calculator, 30 over 8 equal to 3.75. And the O1T is in hours, so 3.75 hours. So this is the answer. In the worksheets, you would have problems with joint variation, but I guess it's the same idea. You would notice how they would word the question as what variables are directly proportional or inversely proportional to other variable, and then you write out the basic equation, solve for k, and then use it to predict.